Okay, so today the plan is to give a brief detour on complex analysis, okay? A brief detour on complex analysis. At most, I'll spend 2 lectures, maybe not even that, okay? And I think that it's a good idea to do this because I find that in a place like Bangladesh, people are taught things, but they're not taught the conceptual ideas. And I think that it's good to have some conceptual ideas. And the more you see these things, the more it'll fill up the gaps. Okay, just 1 second. Okay, so of course this is not going to be a complete introduction to complex analysis. It'll be more like a review or a bird's eye point of view. So what is complex analysis? So complex analysis, it deals with holomorphic or analytical or regular functions, okay? So let me write that. Holomorphic, which is often called analytic, or sometimes it's regular. Regular is no longer used, but it's mostly holomorphic or analytic. Functions f of z, which are defined on the complex plane. Complex plane, such that f of z, satisfies, except at singular points, and those are important, the Cauchy-Riemann equation. Or sometimes called the Cauchy-Riemann conditions. Okay. And what are these equations? So if I take my complex variable z to have a real part, so x is real, x is called the real part, and y is called the imaginary part, although both x and y are real numbers, but y is the imaginary part. And if my function f of z can be written as u, which is a real function of x and y, this is a real function. And another real function, say v of x and y, so this is also a real function. But this is the real part of f, and this is the imaginary part of f. Okay, so always keep in mind, when we say the imaginary part of a number or a function, the imaginary part is the coefficient of I. Okay, but the imaginary part itself is real. Okay, so, and of course, you all know by now that I is minus square root of 1. Okay, so if you have this, then the Cauchy-Riemann equations are, so the Cauchy-Riemann equations are the derivative, the x derivative of u is equal to the y derivative of v, and the y derivative of y of u is minus the x derivative of v. Okay, so these are the Cauchy-Riemann equation. And it's very easy to show, and you should show this, that these two equations, are nothing but the real and imaginary part of this equation. If you take the function, then that function, if you take a derivative with respect to z bar, where z bar is the complex conjugation of z, then it is 0. In other words, it's saying that f is a function of z. So this equation, this very simple equation, if you express it in terms of its real and imaginary part, gives you the Cauchy-Riemann equation. Okay? So is there anyone who hasn't seen the Cauchy-Riemann equation before?
I haven't.
I saw in complex variable course.
Okay.
Yeah, I think I did, but forgot.
Okay.
Yeah,
Hami
I saw
dekhi
it too.
If you have done any complex analysis, but you don't remember the Cauchy-Riemann equation, then it means that you have not learned the essence of complex analysis, okay?
Yeah.
Okay. Complex numbers, you don't need Cauchy-Riemann, but for complex analysis, you need Cauchy-Riemann, okay?